Hello, new recruits. This is your sergeant speaking. Today is a new day for mankind. You need to save the United States of America. Today, you will embark on a journey through the desert. To ensure the safety of all the participants on the journey and to ensure the completion of the journey itself, you need to make sure your math is correct. There will be many challenges on this journey. Be safe. Hello, new recruits. It is important to understand all new vocabulary before embarking on your journey. First, there are x-intercepts. These x-intercepts are located on the horizontal axis where y equals 0. These x-intercepts are our bases. To ensure completion of this mission, we need to travel base to base until we ultimately reach our final base and complete our goal. There is also y-intercepts. These y-intercepts are located on the vertical axis where x is equal to 0. These y-intercepts are our supply centers. These supply centers supply the new recruits with goods they need to stay fully protected on their mission. There are also asymptotes. These asymptotes prohibit the new recruits from traveling from place A to place B. These asymptotes are strict lines that cut off routes. We need to find new routes to be able to complete our mission. There are also holes along the way. To ensure that the safety of all new recruits, we need to ensure that we figure out where all the holes are so no one falls through. On this mission, it is important to remember the phrase ZSON. This phrase dictates what the horizontal asymptote will be. The Z in this phrase stands for 0. This is because in case 1, when the denominator is greater than the numerator, the horizontal asymptote is y equals 0. The second letter in this phrase is S. This stands for same. This is because in case 2, when the degree of the numerator and the degree of the denominator are the same, the horizontal asymptote is equal to the ratio of the coefficients. The third letter is O. This stands for oblique asymptote. In case 3, when the numerator is 1 degree higher than the denominator, you have an oblique asymptote. To find the oblique asymptote, you use division. Finally, the last letter in the phrase is N. This stands for none. This is because when the numerator is 2 or more degrees higher than the denominator, the function does not have a horizontal or oblique asymptote. Our first mission is to find a route to the home base using this rational function. To find the x-intercept, you would make the numerator equal to 0. Then you would factor the numerator and find x plus 6 and x minus 2. Because x minus 2 is the whole, you would solve x plus 6 equals 0, and the x-intercept is negative 6, 0. Then you find the y-intercept. To find the y-intercept of a rational function, you plug in 0 for x. Then you solve the equation. In this scenario, the y-intercept is 0, 2. From the original function, you are able to factor the equation. From there, you will get x minus 2 on the numerator and x minus 2 in the denominator. This means there's a hole at x equals 2. The hole, however, is a coordinate, so you would plug in 2 into the original equation. From there, you would solve and find that it equals 4 over 3. This means the hole is at 2, 4 over 3. Then you can find the vertical asymptote. To find the vertical asymptote, you look in the denominator. In this scenario, x plus 3 is in the denominator, so you make x plus 3 equal to 0. So the vertical asymptote is x equals negative 3. Then you can find the horizontal asymptote. In this case, it is case 2 because the degree of the numerator and the denominator are the same. So you take the coefficients, each coefficient is 1, and you divide them by each other, so the horizontal asymptote is y equals 1. Using the asymptotes, we can figure out the domain is negative infinity, comma, negative 3, union, negative 3, comma, 2, union, 2, comma, infinity. Then there is end behaviors. In this scenario, as x approaches negative 3 from the left, you would plug in negative 3.1 back into the equation and find that it leaves you with a negative number, meaning that as it approaches negative 3 from the left, f of x equals negative infinity. As x approaches negative 3 from the right, however, you would plug in negative 2.99 and it'll leave you with a positive number, meaning that f of x equals positive infinity as x approaches negative 3 from the right. And using all that information, you would plug it onto the graph and solve, and the graph should look like the one listed above. And you would also find that as x approaches negative infinity, limit of f of x is 1, and as x approaches positive infinity, limit of f of x is 1. We were just given a function and had to find a graph. Now let's see if we could find the function given the graph. You can use the vertical asymptotes to find the denominator. There's a vertical asymptote at negative 5, so x plus 5 is in the denominator. There's also a vertical asymptote at positive 3, so x minus 3 is in the denominator. However, x minus 3 is to the second, or is squared, because both sides of the vertical asymptote head towards infinity. Then using the y-intercept, we can find the numerator. The y-intercept is 0, 1. So you would do x minus 1 squared. It is squared because on the graph, it makes a U shape. Lastly, you need to sign test. To sign test, you would plug in 0. Because 0 on the graph is positive, you hope that once you plug in 0 for x, your answer is positive. When you plug in 0 for x, your answer is positive, so you do not need to change the signs. Congrats, new recruits. You have now found a graph using a function and found a possible function using a graph. You are one step closer to achieving your goal and going on your mission. There is one more problem that you may encounter on your journey. For your final mission, you will have to write a graph and draw a graph of an equation that has x-intercepts at x equals 4 and x equals negative 6, a vertical asymptote at x equals negative 2, and an oblique asymptote at y equals x plus 4. Using the x-intercepts, we are able to find the numerator. Because there's an x-intercept at negative 4, x plus 6 is in the numerator. Because there is an x-intercept at 4, x minus 4 is in the numerator. And then using the vertical asymptotes, we can find the denominator. Because x equals negative 2 is a vertical asymptote, x plus 2 is in the denominator. Then we can FOIL the numerator to get x squared plus 2x minus 24 over x plus 2. We can use this to now do synthetic division to find the oblique asymptote. Then when you use synthetic division, you get y equals x plus 4 with a remainder of negative 16. However, you can forget about the remainder. Now we have to graph this original function because this oblique asymptote proves it correct. Lastly, we can sign tests to figure out the lines on the graph. As x approaches negative 2 from the left, f of x equals positive infinity, and as x approaches negative 2 from the right, x approaches negative infinity. Using all that information, we are left with this graph. Drawn closer to scale, the lines on this graph will come closer but still not touch these asymptotes. That is it, new recruits. You have learned all you needed to know to be successful on your mission. Go out and apply this math and be successful on this mission to save America. We are praying for you. Stay safe. Your sergeant out.